In 1945, the US dropped 2 nuclear bombs on Japan, which changed the course of the Second World War. 17 years later, another nuclear explosion changed the course of the Cold War. Except this explosion happened in space. The explosion of Starfish Prime was a pivotal moment in the space race that shaped our perception of nuclear warfare. Join me today as we discuss what Starfish Prime was, the critical lessons it taught us, and why we don't send nukes into space anymore. In the early 1960s, the US launched a series of 5 nuclear tests in outer space known as Operation Fishbowl. Their aim was both military and scientific. The military wanted to study the effectiveness of nukes as anti-ballistic missile measures and how a space-based blast might interfere with electronics, communication, and military operations on the ground. Scientists wanted to know how a space explosion would impact the Earth's magnetosphere and what kind of electromagnetic pulse it would generate. Starfish Prime was the first blast of the bunch. On July 9, 1962, almost 1,500 kilometers west-southwest of Hawaii, a Thor rocket carrying a 1.4 megaton thermonuclear warhead launched for the stars. That's 500 times more powerful than the one that destroyed Hiroshima. 27 smaller missiles loaded with scientific instruments were fired up alongside it to gather data on the blast and its subsequent effects. As the Thor rocket raced upwards, the nuke finally exploded at an altitude of 400 kilometers, about the height of the International Space Station today. And what a sight it must have been. Ionized particles from the explosion collided with molecules in the Earth's atmosphere, creating widespread auroras visible across the Pacific, even as far away as New Zealand. Just below the explosion, the cloudy night sky of Honolulu was lit up for a full 6 minutes. It was as though another sun had emerged at 11 p.m. Radio stations wavered, a siren was set off, and streetlights across Hawaii were even knocked out. The historical context of Starfish Prime is important. The early 1960s marked one of the most tense periods of the Cold War, with the US and the Soviet Union locked in a fierce struggle for global dominance. Both superpowers sought to outdo each other in military strength, political influence, and technological prowess. The space race became a key battleground, and by 1961, the Soviets had the upper hand. They successfully sent the first rocket into space in 1957, and 4 years later, Yuri Gagarin became the first human in space. Pressure on the US intensified as it began to fear the Soviets might develop space-based military power before them. With tensions escalating after incidents like the Berlin crisis, both nations saw the militarization of space as a way to gain a strategic advantage in the Cold War. This sparked a race to develop nuclear weapons, missile defense systems, and other technology that could be deployed in space. Military planners were concerned about how these nuclear weapons could be used in space and what effects the detonation of such weapons might have on global military strategy. More specifically, they were worried about the electromagnetic pulse, or EMP, that would follow such an explosion. An electromagnetic pulse is a burst of electromagnetic radiation produced by a nuclear explosion, especially high-altitude or space-based detonations. This pulse can generate powerful electric and magnetic fields capable of disabling electrical circuits, disrupting communications, and causing widespread damage to infrastructure like power grids, satellites, and radio systems. Back in the early 1960s, scientists knew that nuclear blasts produced EMPs, but the full scale and potential damage of such EMPs was not well understood. Operation Fishbowl was a chance to study these effects more closely. Launched from Johnston Atoll, Operation Fishbowl was a series of 5 high-altitude tests conducted by the US 3 months after Starfish Prime. The US launched the remaining 4 tests in a span of just 2 weeks. The second test, eerily named Checkmate, launched on October 20, 1962. The 20-kiloton bomb, similar in size to the one dropped on Hiroshima, detonated at an altitude of only 147 kilometers. This was rapidly followed by Bluegill Triple Prime on the 26th of October, Kingfish on November 1st, and finally Tightrope on the 4th of November 1962. Bluegill Triple Prime and Tightrope were both smaller explosions that detonated at 48 and 23 kilometers altitudes respectively. NASA defined space as starting at an altitude of 80 kilometers, so I suppose these nuke tests weren't strictly carried out in space. The immediate impact of Starfish Prime struck awe into those who saw it. Aurora stretching thousands of miles, a fireball over Hawaii, all happening in total silence. Unlike explosions on the ground, when a nuclear detonation happens in space, you can't feel a shockwave or hear a sound. There is no mushroom cloud or double flash. there's just a bright ball of plasma, which changes colors like a lava lamp. As charged particles are pushed down into the atmosphere by Earth's magnetic field, these colorful auroras give high-altitude nuclear explosions the nickname rainbow bombs. But the lasting effects of such an explosion are far from sunshine and rainbows. In 1958, U.S. space mission Explorer 1 discovered that the Earth is surrounded by two donut-shaped regions of intense radiation. Today we call them Van Allen belts after the scientist who discovered them. The Starfish Prime explosion released such a quantity of charged particles into Earth's magnetosphere that it altered the composition and intensity of the natural Van Allen belts and even created artificial radiation belts that were stronger and longer than the originals. These persisted for up to a decade, shortening the lifespans of several satellite systems and interfered with telecommunications. But that's not all Starfish Prime did. Remember the electromagnetic pulses I told you about earlier? Scientists knew the blast would emit them, but no one could have guessed just how intense they would be. The EMP from Starfish Prime spanned thousands of kilometers, damaging electrical systems far from the detonation site. Starfish Prime made the world realize just how destructive an EMP can be. I'm Alex McCohen, and you're watching Astram. Join with me today as we learn the likely origins of this rocket and the unsettling implications its existence cast on space exploration in general.